Hello everyone, I am Alexis and I will be talking about the drug with the brand name Imitrex. The generic name for Imitrex is sumatriptan succinate, and the chemical name is this very big long one, butanoic acid. And then the uses for this drug is for the treatment of migraines and acute cluster headaches. So reiterating treatment, because we do not use this for prevention of migraines. We use it for treatment. So that's one of our limitations, is where it's not a preventative medication. It is for treating an active migraine or acute cluster headache. Also, we should only be using this drug if the migraine or cluster headache is the actual diagnosis, if that is the sole diagnosis, and we are sure, because if it is something else going on that may be causing the headaches, we don't want to be using this drug to treat it. And another little thing in there is that if Imitrex injection doesn't work at the first sign or at the first migraine or cluster headache that it is used for, maybe reconsider that original diagnosis, because maybe we're looking at something else here with our body. Here are our contraindications, and we'll move on from there. Significant interactions, so we don't want to be using it with ergot-containing drugs or these 5-HT1 agonists. Both of these will be contraindicated within 24 hours of each other, so we don't want to be using these two drugs together within 24-hour periods of each other. Okay. Fun fact I found, they actually did a trial with two randomized placebo-controlled trials of this injection of 6 milligrams to 1,104 patients with these moderate to severe migraine pains. And they found that the onset relief in those trials was actually less than 10 minutes. So that's really awesome. People were starting to feel the effects of the drug within 10 minutes, which is amazing, being someone who has experienced a lot of migraines and cluster headaches. Another cool thing was that the relief was achieved by 70% of the patients that took it within the first hour, and even better, full complete relief, no pain any longer, was achieved by 82% in one trial and 65% in the other within the first 2 hours of taking it, or sorry, being injected by it. Excuse me. So here I have my line bond structure. I have my nitrogen and hydrogen, sulfur, oxygen, and we go all the way around here. We have our lone pairs that I added in to create octet stability here. We had 2, 4, 6 valence electrons, and we needed that, the last two there, so I added those, lone pair. And then same thing for our oxygens here at the ends of the sulfur. They only have 4 between sulfur and oxygen on each side, so we needed 4 more on each one, and therefore I added those 4 lone pairs. And then same here with our nitrogen. It is only connected to 3 regions so far, so that means there is only going to be the 6 valence electrons connected, and we needed that extra lone pair. And then lastly, same up here with the nitrogen again. So let's expand. Let's expand and look at our expanded structure. I'm going to draw this one out, and we're going to use this as a guide. Let me see if I can zoom out a little bit here. Okay, so ends and bends are carbon with hydrogen atoms connected. So we start off with an end here. So we're going to start off with a carbon. And we know, since that carbon will be connected to this nitrogen, we need 3 more hydrogen to satisfy this rule. Okay, and then our nitrogen is connected to a hydrogen, and this octet, this has already reached octet stability because hydrogen only needs 2 valence electrons to feel complete. And we need our lone pair here still. We're gonna go up and add in our sulfur with our oxygen, and we don't want to forget lone pairs, very important. And then we have a bend here, so we're going to add another carbon atom, and we have 2 extra spots for some hydrogen atoms. And then here we have another little end there. That's a bend. End of some bends. I don't know. That's a bend. And then we've got a double bond to another carbon atom. We've got single bond to a carbon atom down here and a double bond to another. We've got another single bond, carbon, double, single. And then so this only has 3 so far, so we need to add our extra hydrogen in there. Same here, 3, so we're going to add our extra hydrogen. This one is satisfied with 4. This carbon has 3, so 1 more hydrogen there. Same here, 3, so we're going to add 1 more. And then we've got, oops, sorry, let's scratch that. That never happened. We're going down here to nitrogen now. So we're here. And we want to go up. We've got our double bond of carbon here, and we need to add 1 more up here. Got another double bond here with some carbon, and we're going to get back to that nitrogen. We have our hydrogen under nitrogen, and we need that lone pair back in there. And then we go up. We have another bend. So we're going to add another carbon and another bend, so another carbon, and then going up here to nitrogen with our lone pairs because it is only connected to 2 more, which creates 3. And we have some ends here, so we're going to add our carbon in, and then I'm going to go back and look at where we're at here. So we have octet stability there. We need 1 more here, so we're going to add in our extra hydrogen. And here we only have 2, so we need 2 more extra hydrogens. Same here, 2 more hydrogens. And each of these is an end, so we have 1 and we need 3 more hydrogens. Same here. And it looks like we're good. I'm just going to go back through and double check, but it is looking really good with our expanded structure. I think we're good. Okay, so moving on then is going to be the color-coded version of our expanded structure. For the VSEPR theory used to give geometry predictions. So starting with tetrahedral, it is in green here because this is connected to 4 atoms. So we know that that is tetrahedral. And then we go in and we have trigonopyramidal because we are connected to 3 atoms and we have a lone pair there. So that creates that top, and then we have the 3 coming down for the trigonopyramidal. And then we're just going to ignore that that was ever red. That was a mistake made by myself, and there is nothing linear to see here. So we're going to ignore that. It is supposed to be tetrahedral because we have 4 atoms hanging off of our sulfur. Same here with our carbon, 4 atoms hanging off, so we know that that's tetrahedral there. And then it comes in and we've got all trigonoplanar here because there are only 3 atoms connected to each of these carbons. Excuse me. And then we're going to go down and we have our nitrogen, which is connected to 3 with a lone pair. So we know that that with along back here is the trigonopyramidal. And then going up, we've got 3 more tetrahedrals. Sorry, I also made a mistake here. I added that extra hydrogen in last minute and realized that this should be green. So we're going to pretend that's green right now. And that is a tetrahedral with 4 atoms hanging off of it. Same here, we have trigonopyramidal and another tetrahedral. So we're all good. Thank you.